Hi, I'm Alexandre, professor at Federal Institute of São Paulo, Brazil. I'm attending to the 2019 InnovateFPGA with the project AS025 entitled Single Chip Implementation of Multiple Electrocardiogram Arrhythmia Classifiers. The purpose of this project is to implement in hardware using OpenCL the algorithms related to electrocardiogram arrhythmia classifier, which assigns score to one of the 5 classes called normal class, supraventricular class, ventricular class, fusion class, and unknown class. We use the electrocardiogram signals from the MIT BI8 arrhythmia database for developing the project. We extracted both temporal and morphological features presented in the electrocardiogram signals. The temporal feature is related to the time between 2 heartbeats, and the morphological feature is composed of the pulse windowing timescale plane of the continuous wavelet transform. Both features are used as input in a system of networks in which the temporal network is an MLP neural network and receives temporal features. The morphological network is a convolutional neural network which receives as input the morphological features. And finally, the decision network is another MLP which receives both temporal and morphological outputs and assigns confidence to one of the 5 arrhythmia class: normal class, supraventricular class, ventricular class, fusion class, and unknown class. We use TensorFlow to train the system of networks in order to discriminate the 5 classes. First, we used a supervised learning, dividing the whole MIT BI8 dataset in a set of training and testing. After that, we applied an unsupervised learning based on generative adversarial networks, or GANs. So each classifier is optimized for a specific patient. Training the system of networks based on GANs, we have the source networks, the target networks, and the adversarial network. The target and the adversarial networks are trained adversarially in order to optimize its own loss function as a min-max game. At the end, the target network architecture and its parameters, composed of the temporal network, the morphological network, and the decision network, are implemented in the OpenVINO starter kit using OpenCL language. This is the OpenVINO starter kit installed on an eGPU and hosted by a laptop Dell XPS L502 using the free mini PCIe presented in this laptop. So with everything configured, we can see this by the AOCL diagnose command, diagnostic test. Let's launch the compiled host program to start the network system execution. At this time, the FPGA is being programmed and the code is being executed. To demonstrate, we have here the inference of a heartbeat and its output probabilities for the 5 arrhythmia classes. Also, we have here the processing time in microseconds. So with this, we demonstrated the AS025 project developed for the 2019 InnovateFPGA.